All right, today we are diving into a really radical new idea, one that could totally change how we grow everything from the herbs on your windowsill to the giant trees lining our city streets. We're talking about a concept that completely blurs the line between a plant and its own container. So let me just start with this one question. Think about every plastic plant pot you've ever bought. Where does it end up? Yeah, probably in a landfill. But what if that pot wasn't just trash? What if it was actually designed to be food for the plant? To literally become one with it? Well, that's the massive idea behind something called the root sleeve. So here's our roadmap. We're going to look at how this pot actually disappears, what it's made of, and how it makes the plant stronger. Then we'll blow this idea up from your garden to an entire city, see how it's tested to be tough, and finally dream a little about a future of living infrastructure. Okay, so first up, let's get our heads around the basic shift in thinking here. This is not just another biodegradable pot that, breaks down next to the plant. No, this is a system where the pot is actively and systematically replaced by the plant's own root structure. You can see the huge difference right here. On one side, you've got the old way, a plastic prison for roots that just becomes waste. But on the other side, you have the root sleeve. It's an entire integrated system that guides the roots, feeds the soil as it breaks down, and in the end, is completely taken over by the plant. The pot literally becomes the plant. So, you're probably wondering, what in the world is this thing made of? Well, it's not magic, but it is a pretty brilliant recipe. It's a combination of some amazing, high-performance materials straight from nature, all working together. The main ingredient, the backbone of the whole thing, is mycelium. That's the root network of mushrooms. The best way to think about it is like nature's own 3D printer. You can grow it into a shell that's super strong, incredibly lightweight, and porous, giving the plant's roots this perfect, airy structure to get started in. Okay, this next one is a mouthful, but hang in there. Sporopollenin exine capsules, or SECs. All that really means is they're the tough, empty shells of pollen grains, but with all the allergy-causing stuff taken out. So what do? Well, they act like a smart biological glue that gets sticky when wet, encouraging the plant's tiny roots to grab onto the inside of that mycelium wall. And then for a little bit of a high-tech twist, you can add an optional layer, ferropollen. By mixing just a tiny bit of magnetic iron oxide into the pollen, you create a smart layer. This lets you use a really simple low-tech sensor to see how the moisture level is changing inside the pot. In other words, the pot can actually tell you when it needs a drink. So let's quickly recap how this all works together. The mycelium builds the house. The pollen acts like a smart wallpaper that helps the roots get a grip. The structure even has these pre-formed hypha tunnels that are basically highways for the roots to follow. And that optional ferropollen is like a built-in water gauge. The whole thing is a self-contained little ecosystem designed to become nutrient-rich soil. All right, now for what is maybe the most important part of the whole process, the transition. This is where the sleeve performs its magic trick, its disappearing act, and hands over all the structural work to the plant itself. And it's not random, it all happens in 4 carefully programmed layers. First, a special gel pollen band anchors the new seedling. Then that mycelium shell gives it the structure and air it needs to grow. Layer 3 is that optional smart veil for sensing moisture. And then the grand finale. As the shell biodegrades, the plant's own roots weave together to form a root mantle that completely takes over. And this is one of the absolute keys to its success. Remember those hypha tunnels? The mycelium structure has these channels built right in. They're like an open invitation, a roadmap telling the roots exactly where to go. This makes the plant's growth super efficient, and it helps them form a really strong, stable base right from the start. Now, this is all amazing for a single plant in your house, right? But the vision here is so much bigger. What happens when you take this incredible technology and apply it at the scale of an entire city? Well, the basic idea stays the same, but the goals completely change. For your home planter, the goal is simple: a happy, healthy plant with tons of room to grow. But for a big city tree, the sleeve has a much tougher job. Its main purpose is to steer the roots deep down, to stop them from tearing up sidewalks and pipes, a problem that costs cities a fortune every single year. This is where it gets really mind-bending. The urban scale sleeves are designed with geometric patterns on the inside, like a helix or even a Mobius strip. You can think of it like a spiral slide for roots. It physically forces them to grow downwards in a strong, stable pattern, instead of spreading out shallow and causing damage.
It's literally using geometry to speak the language of biology. How cool is that?
Now, an idea this ambitious could easily just stay a cool theory on a whiteboard. But what makes the root sleeve so compelling is that it has a built-in plan for rigorous, real-world testing. It's actually designed to find its own weaknesses so they can be fixed.
They call it a design-to-falsify approach. For every potential risk, they define exactly what failure looks like, and they already have a fix ready to go. For example, what if the pot just collapses too early? The fail condition is clear, and the fix is ready. Add 10% hemp fiber and make the ribs thicker. It's smart, practical, and iterative science in action. And that really is the key takeaway here. This whole framework turns a cool concept into something that's actually a reliable, reproducible method. By actively trying to break the system in very specific, controlled ways, the designers can make it stronger, more predictable, and ready for whatever the real world throws at it.
Okay, so let's zoom all the way out and look at the truly transformative future that this technology is pointing towards. This is about so much more than just a better plant pot. This is about creating city infrastructure that is literally alive. And the team is already dreaming up what's next. Future versions could have features that sound like they're straight out of science fiction. We're talking micro-ribs on the surface that capture air pollutants and turn them into fertilizer, a special mesh that harvests morning dew for the plant, even a built-in cassette loaded with beneficial microbes. And get this, an optional sensor to study if being near this living infrastructure actually reduces human stress. And these aren't just vague hopes. The project has hard targets. For example, with that microbiome cassette, the goal is to reduce the need for fertilizer by a minimum of 15%. That is a concrete, measurable benefit for our planet. So all of this leaves us with a pretty powerful thought to chew on. For over a century, we've built our world with concrete and steel. The root sleeve is asking us to imagine a future where our infrastructure is alive, intelligent, and adaptive. So I'll just leave you with this. Could our cities one day be built not on concrete, but on living, intelligent root systems?